Okay, this is section 2.8, and I'm going to break this up into two parts. The first part here is going to be how to graph a linear inequality. Okay, inequality means we're going to have either less than or greater than symbol in our equation. Okay, so first thing we want to do here as we look at this, we want to put the inequality into slope-intercept form, get y by itself. Okay, once this is done, you're going to graph the line just like before, no different. You've got to graph the y-intercept and graph the slope. Okay, the one thing that's different about this is once it's into slope-intercept form, you're going to need to decide what type of inequality you have. So if it's less than or greater than, it's going to be a dashed line. If it's less than or equal to, or if it's greater than or equal to, it's going to be a solid line. So if there's a line underneath, it's solid. If there's not a line underneath, it's dashed. Also, if it's less than or equal to, it's going to be a shade, you're going to shade below the line. If it's greater than or equal to, you're going to shade above the line. Okay. Once you've done that, now you're going to draw the line and shade accordingly. Okay. So it's really very similar to us graphing our linear equations. It's just we got to worry about is it solid or dash and which way do we shade. Okay. All right. Let's take a look at two examples here. Okay. So as I look at these examples. What is the graph of each inequality? Let's start over here on the left side here first. Okay, so first thing I got to check to make sure, I got to make sure that y is by itself, put it in slope-intercept form. And as you look at this equation, it's in slope-intercept form. So let's identify some things. Let's identify the y-intercept, which is the ordered pair 0, -1. Let's identify the slope. The slope is 3 or 3 over 1. Again, the slope comes from here. Y-intercept comes from there. Okay? And let's go ahead and let's graph this guy now on our graph. So I'm going to go up to the y-intercept. I'm going to go down 1, put a dot. From there, I'm going to go up 3. I'm going to go right 1. So I go up 1, 2, 3, right 1, put another dot. Okay, now that I have my 2 points, I got to figure this out from my inequality. So, as you look at your inequality here, is this inequality, first of all, it's greater than, so is it going to have a line underneath or not? So you got to decide. It's going to be a dashed line, okay? So I'm going to draw a dashed line through my points, like so. Okay, so it's dashed. And it's greater than, so therefore I'm going to shade above the points. Okay, now when I shade on these, I just take and I draw lines like this. I don't color in the whole thing. Okay, so that tells me I've shaded that equation. Now, how do you check to see if you're right? Pick an ordered pair. You pick an ordered pair over here in this spot. Let's say we pick the ordered pair 0, 3 is in the shaded region. 0, 3. I'm going to plug it in. So the ordered pair is 0, 3. I'm going to plug it into this equation. So 3 goes in for y is greater than 3 times 0 minus 1. 3 times 0 is 0. So is 3 greater than -1? Yes, it is. Therefore, I know my solution is correct. You can always check your graph by looking, figuring out, find a point that's in this shaded area and see if it works. Okay, see if it's true. All right, so we got the first one completed here now. Let's take a look at the second one. Again, as I look at this here, we've got to first of all figure out is it in slope-intercept form, and it is. It's in y equals mx plus b. So let's figure out the y-intercept is the ordered pair 0, 1. My slope is -2 or -2 over 1. Okay, and so when I plot these points, I'm going to go up 1, put a dot. From there, I'm going to go down 2 and right 1, put a dot. So again, I'm looking at this guy. Solid or dashed. It doesn't have a line underneath, so it's going to be a dashed line. Okay. So it's going to be a dashed line. Do I shade above or shade below? It's less than, so I'm going to shade below that line. So again, I'm going to shade down here. Okay. Again, you can pick a point that's in that shaded region to test it to make sure that it's correct. Okay. So again, this is no different than what we did with linear equations. The only difference is solid or dashed line, and do we shade above or below. Okay. So this concludes the first part of section 2.8, linear inequalities. Don't forget to watch the second part of the video as well.